All right, welcome back. I'd like to talk about negatives in this video and in conjunction with geometric sequences. So we're going to do a problem like, let's do -1 raised to the n as opposed to -1 without parentheses raised to the n. All right, and I guess both of these should be equal to a sub n. So a sub n equals -1 in parentheses raised to the n, and a sub n equals -1 without parentheses raised to the n. And what is the difference? All right, this one first. The main thing I want to point out here is the parentheses do matter, right? So if we find the first 5 terms of this sequence, I can find that by just plugging in 1, 2, 3, 4, 5 for n. So a1 is -1 to the 1. And as we all know, anything raised to the 1 power is the number itself, so that's -1. And then a2 would be -1 squared. So what does this mean? Well, it means that we're going to multiply -1 to itself. So -1 times -1 is +1. All right, the next one, a sub 3, would be -1 to the 3rd. So that's -1 times -1 times -1. So -1 times -1 is 1, and then 1 times -1 is -1 again. A to the 4 is -1 to the 4th, and hopefully now you see the pattern. It's just going -1, +1, -1. So this is going to be +1. And then a to the 5th will be -1 to the 5th, which is -1 again. So the big idea here you should take away is that whenever the exponent is odd in this situation, like 1, 3, and 5, you get negative numbers, -1, -1, -1. Whenever the exponent is even, like 2 and 4, we get positive ones. All right, so how is that different than this over here? Well, in this situation, if we plug in a 1, we get -1 to the 1. So since the parenthesis is not around, there's no parentheses around the negative and the 1, the exponent only affects whatever it's next to. In this case, it only affects the 1, not the negative. Another way to think of this is the opposite of. This negative right here means the opposite of 1 to the first power. So that would be, what is 1 to the first power? Well, it's 1. So what's the opposite of that? It's -1. All right, a to the 2 would be -1 to the 2. So it means, well, what's 1 to the second power? Well, 1 to the second power is 1. What's the opposite of that? Well, -1. So it's -1 again. A to the 3 would be, think of it as, well, it's -1 to the 3rd, and if I wanted to expand that out, you could think of it as -1 times 1 times 1. 1 times 1 times 1 is 1, and then the opposite of that is -1. All right, so we clearly see that we're just remaining with -1, -1, -1, -1, so a to the 4 is -1, a to the 5 is -1. So your calculator knows this, right? It follows these orders of operations and all. So be careful when you put in, for instance, right here, parenthesis -1 to the 2nd. It'll give you 1, but if you leave off the parenthesis, it'll give you -1. So be very careful. Pay attention to the parentheses. They're important. All right, so how could we expand on this idea? Well, what would a sub n to the -1 power, I'm sorry, a sub n equals negative 1 raised to the n plus 1 power. What would be the first 5 terms for that sequence? Alright, so we'll just plug it in and see what we get. It should be very similar to what we have up here. But when I plug a 1 in for n here, I'm going to get a power of 2, aren't I? So this is going to be negative 1 to the 1 plus 1, which is negative 1 to the 2, which is positive 1. Alright, then negative 1 to the 2 plus 1, which is negative 1 to the 3. Well, negative 1 to the 3 is right up here. That's just negative 1. And the pattern holds just like above, so the next one would be 3 plus 1, which is negative 1 to the 4th. And since that's an even power, I'm going to get positive 1. And then negative 1 to the 4 plus 1, which is negative 1 to the 5th. Since that's an odd power, I'm going to get negative 1, and so on. So this one's negative 1 to the 6th, which is positive 1. Alright, so we see that we can change the pattern slightly by adding a number to n in the exponent here. When I have just negative 1 to the n, the first number is negative, then positive, then negative, then positive, then negative. If I add a 1 to the exponent, then instead of the first number being negative, the first number is positive. So then it's positive, negative, positive, negative, positive. So we can use these little sequences here to make sequences alternate between positive and negative, positive and negative. So an example of that would be, let's say I have a basic sequence that's a sub n equals, let's do 2n. Okay. So let's find these numbers. What are the first 5 terms of this sequence? Well, a1 is 2 times 1, which is 2. a2 would be 2 times 2, which is 4. a3 would be 2 times 3, which is 6. a4 is 2 times 4, which is 8. And a5 is 2 times 5, which is 10. Alright, now if I wanted these numbers to go, let's say I wanted this to be negative 2, and then I wanted this to be positive, then I wanted this to be negative, then I wanted this to be positive, then I wanted this to be negative. What could I do to make that happen? Well, I could use this sequence over here. I can multiply this sequence by this sequence, and that would create this negative, positive effect, because the first number here is negative, the second number here positive, and so on. So let me erase that. Okay. So if I gave you this sequence, first number's negative 2, the next number's 4, the next number's negative 6, the next number's 8, the next number's negative 10, and so on, and ask you to find the explicit rule of the sequence. We could create that. You should be able to create that by combining these two sequences, right? By just multiplying. So here's what that would look like. A sub n is going to be 2n. What that is going to do, it's going to create this 2, 4, 6, 8, 10 without the negatives. Then I'm going to take that, I'm going to multiply it to this sequence up here, which is going to create the negative 1, positive 1. So negative 1 raised to the nth power. So now when I plug into this rule, I should get these numbers. So let's just check it and see if it works. So a sub 1 is 2 times 1 times negative 1 to the 1, right? So all I did was I replaced n with a 1 here and here. So this gives me, what, 2, and negative 1 to the 1 is negative 1, and 2 times negative 1 is negative 2. Alright, so far so good. Let's try a sub 2. So I'm going to plug a 2 in here and here. So 2 times negative 1 to the 2. So that's 4. And then what is negative 1 squared? Well, we already know that that is negative 1, right? I'm sorry, positive 1 right here. A sub negative 1 squared is 1. I'm going to go ahead and slide this up. So that gives me 1, and 1 times 4 is 4. Okay, a sub 3 is going to be 2 times 3 times negative 1 to the 3. So that's 6 times negative 1 again, which is negative 6. And you see how this is going. So I have negative 2. It's a negative. That's an equal sign. So that's negative, positive, negative. The next one's going to give me positive 8. 2 times 4 times negative 1 to the 4, which is 8 times 1, which is 8, and so on. All right, what if instead I wanted it to be positive 2, negative 4, positive 6, negative 8, and so on? Well, then I would use this rule instead. I would multiply by this rule. So it would look something like, let's see, 6. So 2, negative 4, 6, negative 8, positive 10, on and on and on. What is the rule? Well, it's still a sub n equals 2 to the n. But instead of multiplying by this, I'm going to add 1 to that exponent to move the negative from the first term to the second term, right? So negative 1 raised to the n plus 1. So now you can see that when I plug in a 1, I get 2 times 1 times negative 1 to the 1 plus 1. So that's 2 times negative 1 to the 2, which is 2 times positive 1, which is 2. So I get positive 2 instead of negative 2. All right, a sub 2 would be 2 times 2, so I'm replacing it with 2, negative 1 to the 2 plus 1. So that's 4, right? 2 times 2 is 4, times negative 1 to the 3 power. Since that's an odd power, it's going to remain negative, so it's going to be 4 times negative 1, which is negative 4, and so on. So now I've got positive 2, negative 4, then I'll get positive 6, negative 8, positive 10, and so on. And that's it. Thanks for watching.